If you're a non-technical person and you're always wondering how is it that microchips are made, this video is for you. When we're talking about chips, microchips, also known as semiconductor devices, they mainly have four key components. And again, this is simplified, so if you're like a chip design expert, you can certainly put comments below. But the point is, most devices are going to have some type of processing, memory. They're going to have power, circuitry, and then I/O. And I/O, you could think of that actually maybe what the chip does if it's a simpler device. Maybe it's a Wi-Fi chip, or maybe it's a flash memory storage device. So that's kind of just an overview. If you like this video, please click the links below and subscribe. Before we continue regarding the main components of a chip, I also want to just kind of simplify what is it meant when someone says system on a chip. Well, system on a chip you can think of as that's a much more complex device, and what you're really trying to do is you're trying to put everything possible inside that device. So it's literally like all the different components that you need are in the device. A great example of that is if you look at some of the newer Apple Silicon M1 or M2, those have processors, they have memory, they have graphics, they have machine learning, I/O, and so on and so forth. So how does one go about making a chip? What you do is you use a computer language. The most popular is called Verilog, or also System Verilog. There is also a language called VHDL, Very High Level Descriptor Language, that's used in some countries and for some military applications. And there are also higher level languages, are more abstract. Those are things like System C, C, as well as Chisel. Those languages are, as I mentioned, abstracted, so they're very high level, and they're useful because you can design things quick. But the problem is ultimately the outcome, the chip, in the end, is not as efficiently implemented. And so the vast majority of chips are made with Verilog or System Verilog. So if you want to go to school and you want to learn how to make chips, make sure you learn Verilog and System Verilog. Okay, previously we talked about those four blocks that make up the chip. And so now you know that Verilog's the most common language. So what is it that someone does? Do they basically type in Verilog and they make their own processor, they make their own memory, and so on? Well, you could do that, but that would take way too long. That would take far more effort than is required. And so what chip designers do is they leverage what are called IP blocks, intellectual property blocks. And what these are is these are already designed Verilog blocks that do a specific function. You may buy an IP block that is some type of memory, or an IP block that does a peripheral like PCIe, or an IP block for a DSP, a CPU, whatever. And so you get these blocks, and then that allows you to accelerate your design. Then all you need to do is the Verilog to interconnect those blocks, plus any of the extra and the unique things that you are going to put into your device. After you finish your Verilog design that has all these IP blocks, then what you need to do is you need to run it through a synthesis tool. So for example, Cadence makes a tool called Genesis. There's several other synthesis tools. And what this does is it converts Verilog to what's called a net list. And basically that's something that can then be brought in to a simulator. Because when you design, you're going to have errors, especially the early design iterations. And so after you synthesize, you run simulation and you check out to make sure, okay, are things acting the way they should? You run all of these simulations and tests. Okay, after you have your design done and you've simulated it, checked it out, made the changes, and you're ready to move forward, you then will place and route the design. And that's going to depend on where you get it manufactured, how it's done, what tools you use, and so on. But This is basically the kind of the last step before it's manufactured. You run this place and route, you create what's called a GDS, and that file is sent to whoever is going to build the device, and then they go and make the chip. Thank you for watching this video. If you found the content interesting, please click the like button and subscribe. If you have any questions or suggestions for future videos, please put them in the comments.